Our final lesson in Chapter 5 is going to be how to handle elevator problems, and specifically when there's an object in the elevator. And there's really only two types of problems that you will see. One will be a person put in an elevator standing on a scale, and the other would be a mass hanging from a spring scale on an elevator, as I've shown over here. So let me erase this and we can start. So the first thing you absolutely need to know is that you want to set up your analysis and your equations as if you are on the ground watching the person in the elevator go up. So your equations are based on this perspective. Boy, that's a horrible bubble person. But at any rate, so these blue equations that we're looking at over here, that we're going to talk about in a second on how to analyze what's going on in the elevator, is based on a U out here. All right, well, let's start with stepping onto an elevator. And in this case, there's a bathroom scale in the elevator, and that's okay because we know that the force normal will always equal the scale reading. Okay. And when we look at our spring problem, we'll see that the scale reading in the spring scale will equal the tension in the spring scale will equal the scale reading. So let's take a look at our person standing on the elevator. Well, they're standing on the elevator, and let's say the elevator is not moving. So we have the force due to gravity mg down. We have the force normal up. The bathroom scale would read your body weight, and that is because when we looked at force, some of the forces in the y direction equals mass times acceleration in the y direction. We would set up this equation. You are focused, your analysis, only on the person in the elevator. Now, the person in the elevator is attached to the elevator. So when we do the sum of the forces acting on the person in the elevator, we have the force normal up, mg down equals mass times the acceleration of, technically, of the person in the elevator. But since the elevator and the person are together, they're attached, so we're going to say this is the elevator / person. In questions that you will read or be given on tests, they'll just say elevator, but you have to know the person in the elevator also has that acceleration. So in this case, if the acceleration is 0, then we have force normal equals mg, the scale reading reads the body weight. What if the elevator itself and the person inside now accelerates upwards so that we have a positive acceleration for our A? So sum of the forces equals mass times acceleration. And by the way, the one nice thing about elevator problems is regardless of what the elevator is doing, look at our F equals ma equation. Force normal minus mg equals ma. Force normal minus mg equals ma. Force normal minus mg equals ma. The equation doesn't change. The only two forces acting on the person in the elevator is the normal force and mg, regardless of what the elevator is doing. So that is why our force equation doesn't change. So if the elevator is accelerating upward, positive, you might remember being in elevators or recall a time when your knees kind of buckled. Well, the reason your knees kind of buckled when that elevator accelerates up is because the force normal, right, is now mg plus ma when you bring the mg over the other side. So that scale reading is going to read a weight greater than your body weight when the elevator accelerates up. Now, elevators are relatively comfortable to ride because they don't accelerate for a very long period of time. Most of the time, they are moving at a constant velocity, which again means no acceleration. And again, the force normal equals mg, your body weight, and now you feel as if you did when you were on the ground, and the elevator, unless it bumps or shimmies a little bit, you wouldn't know it was moving at all. Now, what happens when the elevator comes to a stop? When the elevator comes to a stop, the acceleration of the elevator and the person inside the elevator is negative. So now the A is negative, and when I bring the mg over the other side, we have force normal minus mg. Force normal equals mg minus ma. So we're subtracting the two, and the scale reading will read less than your body weight by an amount, ma. Well, there you have it. And when the elevator goes down, I did the spring scale version of this problem to analyze what's going on the way down. Notice the sum of the forces equals mass times the acceleration is the same, regardless of what the elevator or the object in the elevator is doing. The only two forces on the object in this case is the spring force, that tension up, and here I'm reminding you that that's the scale reading, minus mg equals ma. The A will be what the elevator is doing, or what the person in the elevator is doing, because it is a person elevator moving together. So when the elevator begins to go down, the acceleration is negative. So we would get a spring scale reading that would be force of the spring, which would be our scale reading, equals mg minus ma, right? I'm going to run off the page here, but that's okay. When we bring that over the side, if the A itself is negative, we get minus ma. So you're going to handle the algebra the same way, and just let the answer be what it is. When the mass is just hanging and the elevator is not moving, A is 0. When you are moving at constant velocity, again, A is 0. And here, when we're coming to a stop, since the elevator is moving down, we need an acceleration upward to keep the object from continuing to go down. So here we have the spring scale reading. Mg comes over the other side, will be equal to mg plus ma. So you don't want to try to memorize each of these cases. You just want to understand how that same force equation, spring force minus mg equals ma, or force normal minus mg equals ma, is applied for the specific problem you're going to look at. And you do have a couple of problems here to look at. And elevator problems, again, are very typical in introductory physics courses. So it's not unusual to see them on the AP test or on tests, and we will take a look at these problems and go over the solutions in class together.